All right, in this video, we are going to go over how to solve not one, not two, but three variables. So real quick, we're going to go over what it looks like. So in a plane, all right, these are three different planes. We got a blue, we got a green, we got a beige plane. If they all intersect at a specific point, that is what's called a solution. Does anybody remember what a solution is referred to as if you have three variables? Anybody remember? For an x, a y, and a z. It's called an ordered something, an ordered triple. Okay? So anytime I ask, if you guys are taking a quiz or a test and I say, what's the solution? And you have to fill in the blank, make sure you fill it in as an ordered triple, where you have an x value, a y value, and a z value. Make sure you don't put any spaces and stuff like that if you're typing it in and you're doing a quizzes. Just make sure you do the ordered triple. Now, that's one possible thing that could happen. Now, if you have three planes that intersect, and they intersect and it forms a line, that's where you're going to have what's called an infinite number of solutions. And so that would be if you had a multiple choice test, that would be where it's called infinite number of solutions. However, there's other ways three planes can intersect. All right? Does this form one line or three separate lines? Three separate lines. So that's not going to be one solution. They have no solutions there. All right? Here we have, what, two different lines that were created. Here, nothing intersects. Okay? So this is where you would have no solutions. So what are the three possible options? Once again, what are the three possible options? One solution, infinite, or known. All right. So right now, what we're going to do, we're going to zoom in real quick. We're going to focus on this problem. You should have it in your journal. All right? What I'd like you to do right now in your journal, could you put x equals something, y is going to equal something, and z is going to equal something. When we're doing this, sometimes, this is an easy one. Okay? The reason this is easy, because technically we can find one of these pretty quickly. Which one do you think we could solve for with relative ease? The very first one, right here, right? Like, what number would you literally have to plug in there to make it equal to a -6? -2 times what number? 3. So right now, we figured out what z is. Boom, we're done. Okay? Now, do you see the second equation? The second equation we are going to write out, except, watch what I'm going to do. Wherever I see the letter z, I'm going to replace it with the number 3. Okay? So there's my second equation. Bless you. All I'm going to do is replace that with a 3. Look at this equation right here. I have x plus 2y plus, now if I plug in a 3 right there, what is 3 times 3? 9. Let's put a 9. Hopefully that's not freaking anybody out there. No. We're taking a 3, plugging it in. 3 times 3 is 9. We're done. Okay? Now, what we're going to do, everybody, I want us to add 3 on both sides. All right? So on this equation right here, what do I want you to do? I want you to add a 3, and I want you to add a 3 to both sides of the equal sign. So you're left with 2x plus 3y equals 1. In this one, I'd like you to take away a 9 from both sides, and you're left with x plus 2y equals 0. And what we've done here is now we do not have a system of 3 variables. What do we have a system of? 2 variables. Very good. Now, at this point, we have to make a decision. Do we want to eliminate all of our y's, or do we want to eliminate all of our x's? And I'm going to say eliminate the x's. And the reason why I'm saying that is it's easier because all I got to do is take this bottom equation and multiply it by a -2. So let's go ahead and distribute a -2 throughout the bottom equation. So what does that leave us with? -2x minus 4y equals 0, because negative 2 times 0 is still 0. And let's just take the blue equation and just place it nice and neat right underneath it. Okay. Now, what are we allowed to do with those two equations? Add them together. So what happens with all the x's? They disappear. They go by. They're 0. All right. How many y's would we have? Close. Not 1, but negative 1y. And that's equal to 1. Now, if you get negative y equals to a positive 1, we would have to divide both sides by a what? Negative 1, or multiply both sides by a negative. And y actually equals what number? Negative 1. So if you ever get this situation, we got negative y equals 1, just know that y will have to equal a negative 1. So wherever you have your y's, it says y equals negative 1, just take it. And right now, we know what y is equal to. It's equal to a negative 1. Sure, let me go back down real quick. Okay. All right, so now, everybody, what we need to do is we need to solve for x. All right? Now, check this out. You guys see the blue equation? Right here? And then the red equation? Which one do you think I could use to solve for x? You want to use the blue or the red? I'm going to use the red. Now check this out. If the red equation says x plus 2y equals 0, and we know what y is. What is y equal to? So watch this. X plus 2 times negative 1 equals 0. What do we get? We get x minus 2 equals 0. Well, what number minus 2 equals 0? No, not 0. Add 2 to both sides. No, not 4. X equals 2. 2 minus 2 is 0. 2 minus 2 is 0. So our final answer is x equals 2. So guys, here's what I want you guys to do. I want you to write the ordered triple. 2, comma, negative 1, comma, 3. This is your answer. Now, everybody see this x plus 2y equals 0 right here? Why did I choose this one? Because it was the easiest one to plug in what? To plug in a negative 1 for y. Let's say you have used the blue one. Watch. I'm just going to use the blue one right now. 2x plus 3y equals 1. If I plug in a negative 1 right there, that becomes minus 3. If I add 3 to both sides, I get 2x equals 4. If I divide both sides by 2, I still get x equals a 2. All right, now we're going to focus on problem number 2. It's very important that you guys write down problem number 2 exactly as it appears. If you do not write the problem down exactly as it appears, and you mess up and put a positive where there's supposed to be a negative, or a negative where there's supposed to be a positive, you will get this answer wrong. So please, carefully write it down right now. At this point, I'm going to color it in 3 different colors. So when I say blue equation, this is the blue equation. Now, if you don't have colors, it's okay. Just have to pay extra close attention. All right? This is going to be our red equation. And then I'm going to go with green. All right, so what I'm going to teach you guys today is a problem-solving process that you can trust in the process every single time. So what I'd like you to do is I would like you to take the first equation, and wherever there's room on your paper, I want you to rewrite the first equation. Okay? You're going to take the first equation, and I'd like you to place it over the second equation. By the way, all my z's, guys, have this little slash in the middle, okay? Because I can't make a beautiful z like they do. I'm just not that good, okay? Then what I'd like you to do is I'd like you to take the first equation and put it over the third equation. So we're doing first over second. I'm doing first over third. So I'm going to move over a little bit to the right so we can take a look at it. We're going to go ahead and do the first equation, which is 3x minus 5y plus 2z equals negative 12. I'm going to put it over the third equation, which is negative 3x plus 5y. So negative 3x plus 5y. Oops, make it better 5. Minus 2z. And that equals 12. Interesting. So make sure you guys get those two equations all set up nice and neat. When you set it up this way, you're either going to be drawn to something or you're not going to be drawn to something. I had a student, they're like, wait a second. Are you guys drawn to the first set of equations, or are your eyes drawn to the second set of equations? Second. Now check this out. The reason why I'm drawn to the second set of equations is, interestingly enough, if I add these together, that zeroes out, that zeroes out, that zeroes out, that zeroes out. Interesting. Would you guys agree or disagree that 0 plus 0 plus 0 equals 0, and is 0 equal to 0? I had a student that just said false, and that concerns me. Because if I have nothing and you have nothing, that means we are equal. We have something in common. We both have nothing. Now, understand, guys, what I want you guys to understand is if this happens, where everything zeroes out and you get two numbers, they're equal to each other, this is where the answer will be infinite number of solutions. Can you guys, here's like, well, wait, whoa, what are you talking about? If you have a scenario where everything cancels out and you get 0 equals 0, you're going to get, that's your answer where it's the infinite number of solutions. Remember what I talked about at the very top, where we have something like this could happen? All right? The first one we had what? We had an ordered triple. This one we have infinite many solutions, okay? So we're done. We don't have to do any more. We're done with that one. Can you guys please put number 3 carefully in your journal, nice and neat. All right, guys, what we're going to do right now is we're going to set things up the exact same way. We have a blue equation. I call it my first equation. We have a red equation. That's my second equation. And then I have the last one right here. So here's what I would like you to do. I would like you to take the first equation and I would like you to carefully place it over the second equation. Make sure everything's nice and lined up. Okay? And then I would like you to take the first equation, once again, the first equation, and I would like you to carefully place it over the third equation. Now, do you see the third equation? Do we have any x's here? No, so we just, hey, put y right here. That says what? Minus 5z, and what's that equal to? Negative 3. Okay? So we're going to set things up right now. So please get that nice and set up. All right, so guys, what we have to figure out here, all right? Do you guys see if we added things together here, what variable would we eliminate if we added things together? All right, so listen, what we're going to do, if we eliminate y in this one, I need us to focus on eliminating y in this one. So whatever you choose to eliminate in one set of equations, you need to choose to eliminate in the other set of equations. That is very, very, very important that you guys hear that. So whatever you choose in one set of equations, you have to choose the exact same thing in the other set. Otherwise, you're going to be mixed up. So right now, let's add these equations together. When we add them together, what are we left with? We're left with x. What's negative 3z minus 5z? That's negative 2z. And when we add 3 and negative 3, what happens? It equals 0. So what have we eliminated? We've eliminated what letter? Yes, it's a minus 2z. Well, we eliminated the constants, but we're focusing on eliminating the y's. Okay, so we eliminate y here. So what do I want to make sure that you guys have to understand? If we eliminate y in 1, yes, you have to eliminate y here. Now, if I eliminated x in one place, you got to eliminate x in the other, and so like that. Okay, now check this out. That's a what? Positive 2y. That's a negative y. So what I'd like you to do is I'd like you to take the top equation, and I'd like you to multiply it by just the number 2. Now, I'm going to take this, I'm going to erase my little line right here, and I'm going to distribute, okay? And 2 times x is 2x. And 2 times negative y is negative 2y. And 2 times 3 is 6z. And 2 times 3 is 6. All right. Now, the reason I chose the number 2 is because that's a negative y, and I'm planning ahead. And I know 2 times a negative y makes a negative 2y, so I know my y's will cancel out. However, look what ended up happening. Not only did my y's cancel out, my x's canceled out, my y's canceled out, my z's canceled out. These did not. What do those add up to? Is 0 plus 0 plus 0 equal to a 12? 0 is not equal to 12. This is a scenario where you're going to have what's called no solutions. Well, dadgum, we did all that work just for no. Actually, we didn't do a whole bunch of work. We were going through the process, and what ended up happening? All the variables disappeared, but we got 0 equal to a 12, and since it's not equal, that's where you get no solutions. So this is the scenario. If you get this, something like this, the answer is going to be no solutions. Whereas before, what was the other one? Infinite. And why was it infinite? Because we got 0 equals 0. Okay? Well, dadgum, are we going to get one that actually has a solution? Yes, number 4 actually has a solution, everybody. All right? So here's what I had to do. Listen, as a teacher, I have to give you the scenario where there's 1, where there's infinite, and where there's none. So we took care of those. So from now on, I'm letting you know, from now on, there's going to be a solution. So put number 4 in your journal, and this is going to be the one where you actually have a solution. We are going to have an ordered triple, an x, a y, and a z. Here we go. Absolutely. I had a student just ask me a question. It was exactly what I wanted him to everybody to understand. You always set it up first over second and first over third. Now, obviously, there's going to be teachers out there. They're like, well, you don't have to do it that way. You're right. You could do second over first and second over third, or you could do third over first and third over second. I just choose to do first over second and first over third. I just do it the same way every single time, and it works out just fine. So I'm going to carefully put the first equation. And of course, there's probably some people out there like, why are you showing them how to do it by hand? Just show them how to put it in the matrix and get it done. Well, that's the next step, everybody. So just be patient, okay? Yes, we will enter the matrix and show you how easy it is to do in the matrix. But right now, we're showing you how to do stuff by hand so that when you do things by hand, you will appreciate the matrix even more. You'll be like, oh my gosh, I am so glad that I know the matrix now. Not the movie, although the very first one was good. There we go. So what am I doing right now, everybody? I'm taking the first equation and putting it over the second equation, and I'm taking the first equation and putting it over the third equation. So please do that nice and neat. It's very important. All right, so here we go. Pay very close attention right now. All right, so guys, this is where we have to decide whether we're going to eliminate x, y, or z. If we add anything together right here, would anything eliminate if we just added things together over here? No. If we added things together over here, would anything eliminate? The y's would. So this is why I'm going to make a choice, guys. Am I always going to start by eliminating y's? No, I'm not going to always start by eliminating y's. The reason why I'm going to eliminate y here, and the reason why I'm going to eliminate y, even though my e is really ugly, eliminate y, is because if I add these equations together, I can get rid of one automatically. So here's what I'd like you to do. We eliminate y here, we got to eliminate y here. So check it out. We're just going to add these equations together. What is 2x plus another x? Good. These y's eliminate. 3z minus a z is a total of 2 z's. And -2 and -3 equal -5. There we have, now we're down to what? 2 variables. Check this out. That says a -2y. So what's the only thing that cancels out a -2y? Positive. That's why I'm going to take the top equation and I'm going to multiply it by a 2. Because 2 times 2 is 4. 2 times y becomes a positive 2y. 2 times 3 is 6. 2 times -2 is -4. Now look what happens, everybody. When I add these together, you're like, why did you multiply by 2? Because I had to multiply it by 2 to get to a what? Positive 2y, so that these would finally do what? Cancel out. 3z plus 6z is a total of 9z. -12, -4 gets me a total of -16. There we go. So now we have, how many variables do we have now? 2. So just write them right over the top. 3x plus 2z equals -5. 7x plus 9z equals -16. Oh, great googly moogly. Now there's not just an easy way to do it. We have to choose one or the other. Because if we add these together, nothing happens. Right? If we add these together, they don't eliminate. Okay, so we have to make a decision. Are we going to eliminate the x's or are we going to eliminate the z's? Eliminate x's? All right. Here's what you got to do to eliminate x's, everybody. Here's what you got to do to eliminate your x. Check this out. You multiply the top by a 7, and you multiply the bottom by a -3. The top by a 7 and the bottom by a -3. So get your calculators out if you need them. 21x plus 14z equals -35. Distribute, distribute, distribute. -21x minus 27z equals a positive 48. Because a negative times a negative equals a. Now we can add these babies together. What happens to all the x's? They get eliminated. Our lives are a lot easier because our x's are gone. We got -13z. Now 14 minus 27 is -13. And 48 minus 35, if you add those together, you get a positive 13. What are we going to do to both sides? Divide both sides by a -13, and z equals -1. Everybody got that? Z equals a -1. Now check this out, everybody. right up here at the very top, right? I want you guys to write this down here. X equals, Y equals, Z equals, and could you please put a -1 for Z? Okay? All right. Now check this out. Do you guys see this nice, easy equation right there? You see that? Let's use it. Let's use it right here. Why am I choosing this equation? Because I see it and it doesn't look too complicated, does it? You can choose any equation that you want. Okay? Just choose one that just has an x and a z, not the one that has an x, y, and a z. So watch this. 3x plus, what is 2 times -1? -2. So check it out, guys. All right? We have 3x minus 2 equals -5. Does everybody understand what I'm doing here? If not, I'll pause and I'll explain. All right. So what do we got to do to both sides, guys? Got to do what? Add 2. Add 2. We get 3x equals -3. Divide both sides by 3. Close. We get what? -1. Now we have 2 out of our 3 answers. We get -1. So right up here, what am I going to do? X equals what? -1. Okay, now this is where it gets fun. You're like, yeah, your definition of fun. Hey, by the way, I still like going to Disneyland and that type of fun too, okay? We get -1. By the way, I've been to Disneyland and Disney World. If you only have one day, go to Disneyland. If you have multiple days, go to Disney World. Okay. If you have lots of money, go to Disney World. If you have a little bit of money, go to Disneyland. You get more in Disneyland, that one park, than you do in one day than you would if you went on one day to the Disney World, because we got one day. All right. Now, do you guys see this middle equation right here? The red one. Check this out. What is x equal to? -1. So I'm plugging in a what? So guys, if you're not sure what I'm doing, I put x minus y minus z equals what? -3. So what am I plugging in for x? -1 minus y minus open parentheses. What number am I plugging in for z? -1 equals -3. So I got -1 minus y plus 1 equals -3. I got a -1 and a... Those cancel out. You're left with -y equals -3. What does y equal? Everybody, as an ordered triple, this is the last thing I want you to do before you shut down your computers and you sign out for the day. Write the ordered triple. -1, comma 3, comma -1. This is what I want you to understand is the answer. That's called an ordered triple. Tomorrow, we're going to talk about the matrix. But today, we learn how to solve a system of how many variables? 3. Have a good day.